And even now, every minute around 3 articles have been are published in PubMed. So there is a vast information, be it in print media or electronic media. And to summarize this information, there is a need to summarize this information due to the demand of evidence and knowledge. Now, if we go to every individual studies, the results might be misleading because of bias and because of even variation in between similar studies. So, knowledge synthesis is required for knowledge translation to bridge the gap in between research and the framed guidelines for working in the medical field. So, these individual studies, the information retrieved from these individual studies may not be of equal quality. They may not be all evidence. And also there is conflict of information whenever these individual studies are gone through. So they are also expected to have some degree of error, like they can be of small sample size, thereby lack statistical power and are prone to chance. They may be performed in a single center, and thereby they may be lacking limited external, they may be having limited external validity or applicability. They're also prone to publication bias, as we know that studies which have got positive results, those who show significant results are more likely to be published easily than those studies which show negative results or which don't show any significant findings in their study. So going through individual studies has got all these pitfalls, and to overcome these and to have a summary of all these individual studies, meta-analysis is needed. So coming to the definition of systematic review and meta-analysis, a systematic review is a review where there is a comprehensive search for relevant studies on a specific topic, and those identified are then appraised and synthesized according to a predetermined explicit method. So the two words, that is comprehensive search and explicit, have been made in bold so as to emphasize that systematic review is different from other types of review. Coming to the definition of meta-analysis, it is a statistical analysis, usually quantitative, that combines or integrates the results of multiple scientific studies, which are considered by the analysts to be combinable. So what we do is we do a statistical analysis by combining the results. It is the results of these multiple studies which are thought to be combinable. We combine those results and finally do a statistical analysis on these results, thereby coming to a pooled estimate or a quantitative estimate of the results, what we intend to find out from this review question. Now, multiple scientific studies, whatever we are including in our meta-analysis, should address the same question. So that is one of the criteria for doing a meta-analysis. And how does this meta-analysis differ from systematic review? The window of search in meta-analysis is broader than systematic review. In meta-analysis, the results of both published as well as unpublished studies are taken into consideration. And it also requires contacting the researchers which are working in that particular field to find out if there is any unpublished work which might have not been published due to publication bias. So what is the importance of this meta-analysis then? It improves the precision of the estimates of the effect. It increases the statistical power to detect a effect. It answers questions which are not posed by individual studies. It can assess the amount of variability among the studies. It settles controversies arising from apparently conflicting studies, and it reduces the probability of false negative results by increasing the power. As in meta-analysis, we have a larger sample. By combining a number of studies, the power increased, and thereby the probability of getting false negative results is decreased. So is meta-analysis just averaging of the results of these studies? No, it's not simply averaging of the studies. A simple average, what will it give? It will give equal weightage to all the results of all the studies, which is intuitively wrong. And some studies are more likely to give an answer which is close to the true effect than the others. And more weight to this studies should be given, which provide more information, like the large number of participants. More weightage should be given to those studies. studies having lower variance, which is the square of the standard deviation, should be given more weightage. Now, the weightage of this is closely related to the width of the study confidence interval. That is, wider the confidence interval, less is the weightage. So, a study which has got a larger confidence interval will be given lower weightage in comparison to a study which has got short or a shorter confidence interval. Excuse. So when can we do a meta-analysis? So after knowing that, why do we do meta-analysis? What is meta-analysis and the importance of meta-analysis? We need to know when we can do a meta-analysis. It's not that on every topic we can do meta-analysis. So there should be more than one similar study which have estimated the same effect. There should be no difference in the study characteristics of these studies. The outcome which has to be measured should be measured in a similar way, and there should be no ongoing meta-analysis on the same research question. So these are the requirements before we can do a meta-analysis. So it has got its limitations also, like it is not 100% unbiased. There are numerous ways in which bias can be introduced. Like also, like if you put the garbage in, garbage will come out. It depends, the results of this meta-analysis depends upon the methodological quality of the primary studies. It is also prone to publication bias, like positive results and significant results studies are more likely to be published with less delay than studies which show negative results. Trials published in English are more likely to be cited than trials published in other languages, and thereby we might, while searching literature, we might miss those studies which are published in other literature since they are in other language. So these are the limitations of the meta-analysis. So what are the resources needed now? Now, an average meta-analysis takes around 22 weeks time for completion, which is near about a year, and around 1,000 working hours. Also, it needs manpower, like an average of around 5 or maybe plus 3, which usually includes a statistician. So these are the requirements for doing a meta-analysis. Coming to the steps of meta-analysis, the first and the most important step is framing the review question. All other steps of meta-analysis relies on this first step, that is framing the review question, which is followed by framing the eligibility criteria, conducting the literature search, doing a study selection and data abstraction, and assessing the quality of the study, followed by data analysis, result presentation, and finally manuscript writing. We'll move on to the first step, that is framing the review question. So how to choose the review topic? It should ideally be selected in an area where a dilemma exists or an uncertainty exists. The topic should be novel or new. It should be interesting to the targeted audience. It should be feasible in terms of time, money, and manpower. Enough literature should be available. Ideally, as we have seen in the request side for doing a meta-analysis, more than one, that is even two studies, similar studies, which have been conducted, identifying a same effect or outcome can be sufficient to do a meta-analysis. But the more number of studies, similar studies are there, the better reliable will be the meta-analysis. Also, we need to know whether the targeted audience or the targeted publication site is a global, regional, or an Indian journal. Depending on that, the review topic will vary, and we should make sure that there isn't one which is already existing. So we should not try to reinvent the wheel which has already been invented. So before beginning the meta-analysis, one should go to the PubMed, can go to the Google Scholar or the Prospero or the Cochrane Library to find out if the topic or the research topic or the review topic what the author tries to do a meta-analysis on is there an ongoing meta-analysis, or is a meta-analysis which has been recently published in these databases available, and thereby he can prevent working on that review topic, prevent that by doing the unnecessary effort. So after choosing the research topic, we need to frame the review question, which is preferably framed in the PICO-ST format, where P stands for population, I stands for intervention, C stands for comparator, O stands for outcome, S stands for study design, and T stands for time frame. So let us, to understand this better, let us do an exercise. So it is an incidence type of review question. And the question is, what is the incidence of post-operative pancreatic fistula in patients undergoing pancreatic or duodenectomy? So you can put your responses in this chat based on and review and frame the review question based on the PICOST format. Yes. So what is the population over here? What is is there any intervention? Is there any comparator? Is there any outcome? Is there any study design? Okay, so I will be showing you how it is written in the PICOST format. So population is patients undergoing pancreatic duodenectomy. There is no intervention since it is an incidence review question. There is no comparator. And the outcome is the incidence of post-operative pancreatic fistula, and study designs can be randomized control trials, observational studies, and the time frame can be made by the authors or the reviewers who wish to review this topic, that is incidence of post-operative pancreatic fistula in patients undergoing pancreatic duodenectomy. As a rule of thumb, around studies conducted in the last 5 or 10 years can be included for your review purpose. Over here, I have included studies published in the last 10 years. That is from 2014 to 2023. Okay, so I think everyone must have got an idea how to frame a review question based on this PICOST format. We'll move on to another exercise, which is a therapy-related review question. And that is, what is the efficacy of antibiotic lavage on normal saline lavage over normal saline lavage in reducing the incidence of surgical site infection in patients undergoing laparotomy for perforation peritonitis? Yes, I would request you to put your responses in the chat box. Sorry, the chat box has been disabled. Okay, so any one of you can unmute yourself and.
No, it's not disabled. It is active only, but no responses.
So someone messaged me that it is disabled.
Let me check again. Actually, I have allowed you also to manipulate. You can do that.
Yes.
I have allowed all the participants to manipulate.
Those who have got the can also unmute we are not able to access the chat. I don't know, maybe due to some reason. You can unmute yourself and tell. what will be the review question based on the question form? Yes, anyone?
Now they can try, I think. So now I think everybody can access.
Yes, sir. Yes, you can unmute yourself or you can type your responses in the chat box. Yeah, I can see one of the response where the population is patients with perforation peritonitis. Yes, patients undergoing laparotomy. Very good. Intervention is antibiotic lavage. Good. Yes. So I think a few of you have got to know how to frame a review question based on this QST format. And this is the answer. That is patients with perforation peritonitis, which are who are undergoing laparotomy. Okay, a few of you have written patients with perforation peritonitis. A few of them have written patients who are undergoing laparotomy. The intervention is antibiotic lavage. Comparator is normal saline lavage. The outcome is incidence of surgical site infection, and the study design are clinical trials, preferably randomized controlled trials. The time frame over here, I have fixed over here as our articles published in the last 10 years, but it is up to the reviewers or the authors. They can select any time period frame, that is maybe 5 years, 15 years, or it can be kept blank so as to include all the studies which have been published till date. Okay, for those who have got it right, fantastic, and for those who have got it wrong, I have another exercise for you. Okay, here is an etiology review question. Is consumption of smokeless tobacco associated with oral malignancy in Indian adults? Yes, please put your responses in the chat box. In the PICOST format. You can also unmute yourself. Okay, so this is the, okay, we have got, yes, good. We have got some responses. Population, Indian adults, very good. Intervention is smokeless tobacco. Comparator is, okay, fine. Some have written no intervention, no comparator. Some have mentioned that tobacco is the comparator. Outcome is oral malignancy, and the studies is observational studies. Okay, if you have got it right, let's see the correct answers. Okay, so population, that is adult males and females of India. Exposure is smokeless tobacco consumption. Comparator is not using smokeless tobacco. Okay, it is not that smokeless tobacco, if it is an exposure, comparator cannot be tobacco. It should be not using smokeless tobacco. Outcome is oral malignancy, and the study designs are case control studies and cohort studies, which are observation studies. And the time frame can be since all studies till date, or as a rule of thumb, we can consider last 5 years or last 10 years articles. So now from here, we have got to know that a review question decides everything. So it will decide the eligibility criteria of the studies, what type of studies we are going to include in our review, the literature search, okay, what are the terms which we are going to use while doing literature search, what data we are going to extract after doing the literature search, what type of analysis we are going to do, and finally, how are we going to interpret the results. We'll move on to the next step, that is framing the eligibility criteria. Okay, so this eligibility criteria is nothing but a combination of inclusion and exclusion criteria. The inclusion criteria are the characteristics which make the study to be included in the review, and exclusion criteria is something which makes the study excluded from the review. And we should take one important thing into consideration, that is avoid mirroring while framing the eligibility criteria. Why we do need this eligibility criteria? Because there are millions of literature available, and it is impossible to go through every literature and see if it is satisfying our review question. So for that, to see that which article is useful to us, which article is not useful to us in a rapid way, we need to frame this eligibility criteria. So let's move on to another exercise on framing the eligibility criteria. It's the same example which has been discussed previously, which is a therapy review question. And the question is, what is the efficacy of antibiotic lavage over normal saline lavage in reducing the incidence of surgical site infection in adult patients undergoing laparotomy for perforation peritonitis? We have already framed the review question, and it's like this. I would ask you to frame the eligibility criteria, that is inclusion and exclusion criteria, based on these review questions. Please put your responses in the chat box. If you wish to unmute yourself, you can unmute and give the responses also. So here we need to make some, like these are the studies we are going to include, these are the studies we are going to exclude. These are the studies, if the population is having this characteristic, I'm going to include it. If it is having that characteristic, I'm going to exclude it. If it is not assessing this outcome, I'm going to include it. If it's assessing this criteria outcome, I'm going to include it. So these are the things which you have to consider while framing the eligibility criteria, that is an inclusion and exclusion criteria. Yes, patients with perforation peritonitis, patients undergoing laparotomy, 18 to 65 years of age group. Okay. So here when we take all these exclusion as observation studies, immunosuppressed patients, very good. Yeah. So I see some good responses, and these are the results. Okay. So here we are not actually including the people, we are including and excluding the studies. So it should be, we should be including the studies where the population is adults undergoing laparotomy for perforation peritonitis. So if there is a study which has been conducted on children, or say like it is on some special population which are immunosuppressed, and we know that doing a study on these patients is likely to have unusual outcome. So we are going to exclude those studies. And we're also going to include those studies, particularly when antibiotic lavage is compared with normal saline lavage. We can't use a study where something else is given instead of antibiotic and compared with normal saline. And the study designs, what we are going to include is preferably randomized control trials. And the time frame I have chosen over here is 10 years, and preferably those are studies which have been published in English language. So the exclusion criteria is that review articles, case series, case reports, retrospective studies, studies conducted in special population like immunosuppressed people, studies not assessing the incidence of surgical site infection as an outcome, where surgical site infection has not been assessed as an outcome, those studies won't be any useful. So I need not consider those studies for my review. Studies assessing surgical site infection on criteria other than the CDC definition. Wish to see that based on the CDC definition, how many studies have assessed the outcome there is surgical site infection. So if some studies have assessed surgical site infection based on any other definition, I would like to exclude it. So these are the so we have seen that based on this review question, it is very easy now to frame your inclusion and exclusion criteria. Okay, so those who have done, it's fantastic. We'll move on to the third step, that is conducting the literature search. So before we move on to this step, I would expect and would like to know there is a difference between website, search engine, and a database. So what is a website? So it is a particular location in the web or a site in the web where you can find out the literature. Say, for example, JAMA surgery. Whereas a search engine is a search machine. Say, for example, Google Scholar, where if you know the author, if you know the title, if you know the journal, the issue, you may search that article and include it in your review. There is another thing called database. The easiest example of the database is a telephone directory, where in case of a medical database, the most common or the most important three databases are PubMed Central, Embase, and Cochrane Library, where the medical literatures have been stored and arranged indexed in a manner so that it can be easily retrieved. So there is a difference in between website, search engine, and a database. So there is something called grey literature also. These are unpublished academic, business, government, or industry print or electronic literature that are not controlled by commercial publishers. So these are the literatures which have not been published in electronic or commercial journals, and thereby it is likely to be missed while doing a literature search. So what are the sources of information retrieval? We need to search subject-specific journals. We need to search the citations from most relevant articles. We have to search electronic databases, and also we have to give an attempt in searching the grey literature. Like if we come to know that a particular author has been working in this particular research, we should contact that particular author and either by mail or by telephone and ask if the results, what were the results of his studies, and there could have been a publication bias. Those results would have been negative or insignificant, and that is why the author has not published it in electronic media or print media. We should also discuss with experts in the field and thereby see if any ongoing trial is going on based on the particular review topic. So as I've already mentioned, these are the three important electronic databases, that is PubMed, Embase, and Cochrane Library. So this particular figure shows the position of the grey literature. Here we can see that the colored circle is the articles which are of our interest for completing the review process. Some of the articles which are in PubMed are also there in Cochrane Library. They are also in Embase. Some of the articles which are in Cochrane are also in Embase and also in PubMed. Some of the articles which are in Embase are also in PubMed and Cochrane Library. But there is also a portion which has been shaded orange, which is the grey literature, which is not in Cochrane Library or Embase or PubMed. So since it is unpublished, so it is likely to be missed while performing the review. So coming to the principles of search, searching literature. Literature search can be done by using controlled vocabulary like mesh term and entry. Mesh term in case of PubMed and entry in case of NBase, or using field search. It can the common Boolean operators like and, or, not are used while doing the literature search. So I'll be demonstrating you how to do use this controlled vocabulary and field search and Boolean operators for searching the articles for your review. So we will be going to the PubMed page. Can everyone see my screen?
Yeah, we are able to see.
So I would advise everyone before beginning the literature search to create an account in PubMed. I have already have an account, and I can create this account by using Google or Facebook or even Microsoft Live. I have my account in Microsoft Live, and with this account, I will be logging in through into the PubMed. The advantage is that whatever searches we are doing it, that will be saved. Also, what we can store those searches, and we can also export those searches. So that will be the advantage of creating an account in the PubMed. So now the basic way of searching is in our example we was on therapy review question, which was what is the efficacy of antibiotic lavage over normal saline lavage in reducing the incidence of surgical saline infection in patients undergoing laparotomy for perforation peritonitis. So here what we can do is that if we search antibiotic lavage, perforation peritonitis. So if we search, we are going to find around 148 results. Okay. So, and this is, and I would say that this is not the pro method of doing it. So the pro method is by going to this advanced section and putting here your search term. Here we can search in all fields. All fields means in all the parts of the article, be it your title, be it your abstract, be it your keywords, introduction, methodology, results, discussion, or conclusion. If that word is there in any of these fields, it will be picked up by this search and will be shown in your results. But what term to use? So that to know that there is the controlled vocabulary. For PubMed, it is MESH. So it stands for medical subject headings. So we need to go to the MESH browser. So in Google, you can type MESH browser. Go to the first website, that is, and here there is medical subject headings 2024. So here we are searching antibiotic. So let me type the word antibiotic and see what is the medical subject heading for the word antibiotic. So there is one, yes, that is antibacterial agents. So suppose there are some studies which have, instead of using antibiotic, they have used antibacterial agents. Also, it will search if somebody has used antimicrobacterial agents. Also, it will search if some have used bactericidal agents. Also, it will search those articles. So it becomes, so the search will include all those articles which have include all these entry terms. Whatever you're seeing over here, that is antibacterial agent, antibacterial compound. So it is not, we don't have a surety that this particular author who has published this article has used antibiotic in his study. He might have used antibacterial agents, he might have used antibacterial compound, be it antibactericidal agent, something like that. So this, by using this mesh word, we can include all those entry terms. Okay. Similarly, if we are thinking of lavage. So we find that it is therapeutic irrigation, so which includes douching as well as lavage. So we'll remember all these mesh words and use this mesh words while doing our search. So next is perforation peritonitis. So it's also possible that sometimes these words may not be having a mesh. So in that case, we need to divide those words, make it more simple, and again search. So here we are finding it's taking some time. So there are no results for perforation peritonitis in main heading terms. So we can further make it more simple, like writing peritonitis. So the mesh heading for peritonitis is peritonitis itself, which includes entry terms like primary peritonitis as well as secondary peritonitis. So we have one more word, like we can also see whether this articles which have been published are have assessed the outcome, that is surgical site infection. We'll find out what is the mesh term for surgical site infection. That is surgical wound infection. Okay, so we now know what are the mesh terms for antibiotic, that is antibacterial agent. The mesh word for lavage, that is therapeutic irrigation. The mesh word for perforation peritonitis, we can use it just peritonitis. And the mesh word for surgical site infection is surgical wound infection. So what we are going to do, we are going to put all these in this field. Say here, antibiotic, sorry, antibacterial agent, antibacterial agent. Then we have to press on this add, and we have to add, and the drop down will come, we have to add to history. So we can see that, and based on if we search just antibacterial agent, there are around 8.4 million, 8.4 lakhs articles in PubMed. If we use the term therapeutic irrigation, we add it, we add to history. So there are 57,000 articles. Then we use the word peritonitis, add it, add to history. There are around 2 lakh articles. And finally, surgical wound infection. Add to history. So there are 59,950 articles. So now what we are going to do is we are going to combine all these with the Boolean operator and. Like we have, and under the actions, there are some 3 dots. Here we have to add query. We see that it has come to this box. Then on the second, therapeutic irrigation, add with an and. Then the third one, that is peritonitis, add with an and. The fourth, that is add with an and, that is surgical wound infection. And then we add this to history. So we see that there are only 83 articles. Now we have made our search. We can now focus our search on these 83 articles. We can go search the title and abstract. We can go to the title and abstract and see if it is fitting our inclusion and exclusion criteria. If whatever studies which have been selected based on the title and abstract can then further the full text can be retrieved, and we can go to the full text and see whether it has been conducted in the same method, the outcomes have been assessed in the similar manner to be included in our review. So how can we save this now? So in this 83 number, we have to click it. We come to this page. So here there is, suppose now we are doing it on the last 10 years. So we can just like in other websites, we can toggle this wheel and bring it to our source of 2014 to 2023. So we see only 7 results based for this particular topic. Okay. So if we are willing to include all the studies till date, we can again select all those back. And then here we can also save it to our system. We can email it to, suppose you are working under a guide, you can email those search results to your guide, or also you can save within your account in the PubMed. Like we can, in the collections, I have already, we can create a new collection, or you can add to a existing collection. All here the selection is all results in this page, but I want to select all these 83 results. So all results I can do and add to existing collection. I have already have an existing collection, there is antibiotic lavage perforation peritonitis. I can save it to that or create a new collection and say write antibiotic only. And add it. So it gets saved to my collection. Whenever I need, I can go to that collection and see those results and also save it to my system. How to save it into your system? You have to go click over here, that is save, then all the results and format. Preferable will be PubMed, but there are other formats like CSV, abstract, PMID. This is the format which is the most appropriate, so as to since it will be containing some information regarding the title and abstract also, which will be helpful while screening the articles for inclusion into our review. And we can create a file. So the file has been created and it has started the download. So we can we'll be seeing later how to use this file. Okay. So the way I have done in PubMed, the similar way is done in Cochrane and also in NBase. PubMed, the access is free, whereas Cochrane may require some institutional access, whereas access to NBase is usually on subscription basis. So I don't have an access to that. But the search of literature is more of similar as we have seen in PubMed. Here we have used the mesh terms, whereas in NBase we use the empty terms. There we can find out what are those empty terms and also put those words while doing the literature search. Okay. So I hope everyone has understood how to do this literature search, how to first find out the mesh words using the mesh browser, and then use those words under the advanced search in PubMed and find out the relevant articles for our review. So we'll move on to our next step in meta-analysis. That is study selection and data abstraction. So what is the purpose of this screening? There are multiple sources of literature. Now, as I have already said that I have shown you in PubMed how to do the literature search and how to download the results. Similarly, we will be searching in Cochrane and also in NBase. Now, after we combine all those searches, there may be some duplicates. Okay, and there may be some overlapping. So we need to remove these duplicates. And also we need to remove some after going through the title and abstract, we may find that okay, this is not a randomized control trial, it is a review article. It is not a randomized control trial, it is a case series. It is not a randomized control trial, it is a case report. And we need to exclude those articles. So those irrelevant results, those which have some of the studies where only the abstract is there, that study has not been, the protocol is there is no study conducted. So we need to exclude all those selected articles from our review before, and thereby select only those articles which are appropriate for our review. So how to do the screening and abstraction? First is we have to choose our tool, which I'll be telling you in my next slide. Import in your search results. The results which I've downloaded from PubMed, those results have to be imported to that tool. Title and abstract screening. So we have to go through the title and abstract of each of these search results, and then find out, screen that which articles are acceptable or are eligible for including in the review based on the title and abstract only. Then we'll go to the full text screening of those articles which have been found eligible in the title and abstract screening. So say from 83, now I'm getting 10 articles which I feel that they are eligible. Then the full text of those 10 articles I'll be screening and seeing that the methodology is appropriate or not, the outcomes has been assessed in a proper manner or not, in which I intend to do my analysis. And finally, we'll be doing the data coding and abstraction. So these are the tools. Okay, there are various tools. Some are free, some are paid, and some require some import access, like say the Covidence. It is a Cochrane tool used for Cochrane reviews, and those who are doing Cochrane reviews can have access to this Covidence tool. So here we can see that Ryan is free, Revman is free, Mendeley and Zotero is also more of free. So Ryan can be used for screening and bibliographic management. Covidence can be used for all. Mendeley and Zotero are used only for bibliographic management, whereas Revman can be used for bibliographic management, data abstraction, analysis, as well as review writing. So what information to extract will depend upon the review question and the objectives, as well as the design of the studies included. So I'll be showing you how to screen and how to abstract. So here we'll be using an internet portal which has been powered with artificial intelligence for screening, and that is Raya. This is doesn't require any subscription fees. It can be accessed free. So first thing is that you need to create an account. It is very easy. You need to get started and register yourself. After registering, we need to sign in. I've already registered it, and I'm signing in. So you must be remembering that I have saved the results of my search in PubMed, and now I want to import those results into this AI internet portal. So I'm going to start a new review. Say I give it a name like demo underscore antibiotic. Research field, medicine and human health. Review type, review type is meta-analysis. Review domain is biomedical. Description can be left blank and we need to create it. So after this, you can now see on the right side that what are the formats in which we can import our results. And download example, EndNote export, refman, bibtext, CVS, PubMed XML, new PubMed format, Web of Science, CIW format. So these are all the formats in which the results can be imported. So we have downloaded our search results on this format. So I've already downloaded. So I'm going to select the file over here. It's over here and I open it. It has been uploaded. Then I press continue. So after what happens is that all the selected articles get pulled over here. So here there are multiple options, but the first step is to detect duplicates. Here, since we have selected it only from a single database, there is unlikely to be any duplicate. But suppose if you have selected from Cochrane, from NBASE, and from PubMed, there are likely to be duplicates. So we need to first detect those duplicates. And if we are sure that these are the duplicates, so I'll show you how to do that. Okay, so here it is showing that 0 duplicates are found. Yes, it's for obvious reason because it is only from a single database. So there is unlikely to be any duplicates. So if there are duplicates found, it will be showing it column over here that these are the duplicates. So we need to select, like I'm selecting over here. It will be showing this and it will show me the duplicate which they are thinking that is the percentage of matching happening, and I have to resolve, either go through both the abstract of both these things and give a decision whether it is actually duplicate or it is just an error which has been picked up by this internet portal, that is Rayan. So after resolving these duplicates, what we are going to do, we are going to now find out whether this particular, we have to go through this all 83 entries or the studies and go through this abstract and see whether it is fitting into our eligibility criteria for being included in this review. Like this intraoperative surgical irrigation of surgical incision. So it is an irrigation of the surgical incision and it is not abdominal lavage. So we are going to exclude it. The reason we can give is wrong study type. Okay, it is not there. So what we can do, we can add, right? Wrong study topic. So it's a wrong study topic. There is a reason. So whenever we are going to exclude it, we have to give a reason it, so that at the time when we are writing the manuscript, it will be easier to draw a flow chart which shows that this many number of articles we have retrieved from PubMed, Cochrane, or NBASE, and this many number of articles we have found to be duplicate. This many number of articles we have excluded because it was a wrong study topic. This many number of articles we have excluded because it was a wrong publication, or a wrong study design. If it is a review, we have to exclude it. So these things we need to find out by doing this. So here, antibiotic irrigation during pancreatic duodenectomy to prevent infection. So it is an irrigation which is done in the peritoneal cavity. But here we can say that it is done during pancreatic duodenectomy, which is not a perforation peritonitis. So it is also excluded, and the reason we give it as wrong study topic. Wound and intra-abdominal infection. So we move on to the third one. So this looks to be like a review. So we exclude it, and the reason we give is wrong study design. Similarly, we have to go through each and every article and either include or exclude. Wherever there is a doubt, we can mark it maybe. So after doing all these things, what we're going to do is that we're going to share this particular review with another researcher. So ideally, what is that? Screening has to be done by two researchers, and whenever there is a discrepancy in the opinion, we need a third arbitrator to find to a solution or to come to conclusion whether this article has to be included for a review or not. So here, this is our article. This is our search, which has been labeled as demo antibiotic. There are 83 articles. I can invite by giving him as a collaborator, and can write the mail IDs. I can write around multiple email IDs separated by commas. And reason I can put a message that hi, welcome. I welcome you for as a collaborator in the systematic review, and give it an invite. Okay. So what happens is that he also comes to see this searches, but is not able to see the decisions what I have made. This is just for blinding, so that he doesn't get biased by my decisions. He has his own opinion regarding whether this particular study is appropriate for a review or not. And finally, what is that since I am the owner of this particular review, so I at the end what I can do is that I can off the blending, and I can see what is the agreement in between the reviewers based on a particular suppose if this is I have selected as no, but he has selected as he or she has selected it as to be included, then we go to a third arbitrator to finally come to a conclusion whether this has to be included or not. If I select, suppose this one as this is not to be included, but if I say included, it will become green. So what will happen is that finally when I off the blinding, it will be showing green and then red. So this is which will indicate that this needs to be discussed with an arbitrator to finally come to a conclusion whether this article has to be included or not. So I have done this, and I'll be showing you what are the results which I have got. Yeah. So I finally have come to a conclusion that 5 are to be included, 77 are to be excluded, and 1 is maybe. Maybe I have to discuss with the arbitrator, or maybe I want to see the full text to finally come to a conclusion. So what I'm going to do is that these 5 or studies which I have selected, I have to export it to one more new search, and finally start my review again for the full text. So I'll be creating one more now. Like I can give it a name, demo underscore antibiotic full text, medicine and human health, meta-analysis, review domain biomedical, and create. So I've created it. Then I go back, go to this one, go to this included articles. Here what I do is that I have to copy filtered 5. I'll be copying it, and I'll be assigning a new target. That is the search which I have already created recently. Okay, that is a demo antibiotic full text, and I'll copy this. Only these 5 articles which have been screened by from the text from the abstract and keywords will be copied to that new review. So I go back to all the reviews, and I select this one where I find 5 articles are there. Okay. So now again, this I'm going to, what I'm going to do is that I'm going to select all this, and now I'm going to go to the full text. Now the full text is not available over here. So what I can do is that with the help of this DOI or the PubMed ID, I can retrieve the full text. I have already downloaded the full text. Now what I'm going to do is that I'm going to add it here to your launch. So I have already downloaded. It's already in my downloads. So I have uploaded. Efficacy of metronidazole, upload, add PDF files. So I do it for all those 5 articles. Then what I do is that I share this with another reviewer, that is by inviting him to see. So both of us will be going through the full text of the articles, and then finally we'll be deciding whether to include or not. So like we have done it for the abstract and the title, we are going to do it for the full text also to finally come to a decision whether this has to be included or not. Okay. So here, what I have come to know that after I have included this in my initial screening of abstract, but when I go to this full text, I have come to know that here it has done metronidazole lavage, but it has not compared with normal saline lavage. It has just compared metronidazole lavage in emergency and elective setting. So what I do is that now here I am excluding it from my study. The other things I'm going to, other articles I'm going to include it. So finally, what is that? We are left with 4 articles out of 5 for analysis. And we are going to download all these 4 articles and do the data abstraction. So data abstraction is just collecting the data from these articles, be it some qualitative data, be it some data on the methodology, on the author, where was it conducted, how was the randomization done, whether there was any blinding done or not. So some information based on the characteristics of the studies, characteristics of the intervention, and as well as some qualitative variables like the outcomes, whatever we are intending to study. Those things we have to make a spreadsheet. Okay, so I'll show you now. So based on the same review topic, that is what is the efficacy of antibiotic lavage over normal saline lavage in reducing the incidence of surgical site infection in patients undergoing laparotomy for perforation peritonitis. So I have made a data abstraction sheet. So here I can see that it's an Excel sheet where I have given I've labeled the columns into different variables which are required to be filled up. Each row will correspond to the study. Now there are 4 studies, so I'll be assigning each study one ID, which can be 1, 2, 3 or A, B, C, D, any number. I will write the author name, the location where the study was performed, the year of publication, what was the study design, whether it was an RCT or some other type of clinical trial, what was the participant characteristics, whether whether all were adult patients or some pediatric populations were included, so that whether to include this into our study or not, it will give us an idea. The sample size, the intervention, what was done in the intervention, what antibiotic was given in the intervention, in comparison.
How you are left with another 5 minutes only. Huh?
Yes.
You have taken more than an hour.
Yes, sir. So this is the duration of evaluation, the number of participants. So this is a format in which I'm going to collect the data. And finally, with the help of some software, I'm going to do this analysis. Okay. So here you're going to collect the data and keep it. And with the help of some softwares, we are going to do this analysis. So we have now we have understood that what are the information we have to extract and how to create a data abstraction sheet. While doing the analysis, also we need to assess the quality of the study. Usually, non-randomized control trials are the quality is assessed using ROP2, which is a Cochrane collaboration tool. Other tools for assessing the risk of bias are modified down and black checklist for systematic review, Newcastle Ottawa quality assessment scale for non-randomized studies, Robbins 1 for non-randomized studies, MMAT for mixed method studies. So these are some tools which can be used for assessing the risk of bias in the studies. And this publication, we also need to find out the publication bias, and these are the tools which can be used. One of them is funnel plot, Gauss regression, Duval's and Tweedy's trim and fill, cumulative meta-analysis. So these are some tools, and describing each of them is beyond the scope of this meeting. We need to you can search over in the YouTube to find out more details regarding each of these tools used for assessing the risk of bias and publication bias. We'll move on to the next step, that is data analysis and result presentation. There's a common template of items for data synthesis. Like
recording stopped.
We need to find out the effect size, the pooled estimate, the effect model, forest plot, heterogeneity, sensitivity analysis, and publication bias.
Recording in progress.
All these are to be done by your statistician, and that is why including a statistician in your team for doing a meta-analysis is very important. These are the types of tests based on the data. For binary data, we use log odd ratio. For continuous data, standard mean difference, Cohen's d. And for correlation data, we can use Fisher's Z test. And all these tests can be interchangeable. For identifying the heterogeneity, that is how heterogeneous are the study populations among the different studies, we can use the I-square statistics, which is usually expressed in percentage, or we can use the Cochrane Q test. Before using before doing the analysis, I would like to tell a few points on what is fixed and random effect model. So what is fixed effect model is that it assumes that all the included studies investigate the same population, use same variables and outcome definitions. So when this is the condition, we used fixed effect model. And this assumption is usually unrealistic, and the research is prone to several sources of heterogeneity. For example, treatment effect may differ according to the dosage level, local, and in giving the example of our review topic, that is on antibiotic lavage. Here it can be that some of the researchers might have used antibiotic, say amikacin, some might have used metronidazole, some have used clindamycin or any other drug. Some have used normal saline at the end of the surgery, some have used normal saline lavage at the beginning of the surgery. So there might be some discrepancy also in the characteristic of the population. Like in some studies, most of the population studied were of the older age group. Some studies are the mean age group of the median age group of the population was, say, around 40-60 years. So there might be some heterogeneity in this study characteristics. So using fixed effect model is very rare while doing the analysis. So what we do is that we use the random effect model. So it is used to synthesize effects of heterogeneous research, and the weighted average of the effect size of a group of studies. There is achieved in 2 steps by inversing the variance weighting and by unweighing the inverse variance weighting by applying a random effect variance component that is simply derived from the extent of the variability of the effect sizes of the underlying studies. So these are most of all these things are usually done by the statistician, but we need to inform the statistician that this is going to be a random effect model. And these are the softwares which are used for the analysis, that is Excel, R, Jamovi, and Revman. All these are available without any subscription, and they can be accessed by anyone while doing the analysis. Before I end, after you have done the analysis and you've got the results, we need to report it using certain guidelines, that is Prisma guidelines or Moose guidelines. And before doing a meta-analysis, we need to register the protocol of this meta-analysis in the Prospero website, which is like prospective registration for systematic reviews, which is we prospectively register before beginning the analysis part. Particularly, we can do some preliminary searches, we can do some sort of initial search, but before doing the analysis, we need to register the particular review topic in the Prospero and get it registered so as to finally increase the acceptance of our published manuscript in future in the good journals. So most of the journals they ask for a registered protocol in Prospero while we submit our manuscript for publication. So these are the references. So most of the topic what I have discussed over here is from the SWAYAM portal, which is an introduction to systematic review and meta-analysis, and there are some other YouTube videos also, which I have referred to while making all these slides.
Yeah, that was a great lecture, Debasis. Fantastic. So, any questions, please unmute yourself and ask. And meanwhile, while you are asking the question, I would like to thank Dr. Pavitra and Dr. Ram, who have joined from a distant place. So they were our alumnus long time back. So thank you for joining. Now you can ask questions by unmuting yourself. So one question I would like to ask is, what is this network meta-analysis, Debasis?
Sir, like when multiple interventions are being studied simultaneously, like in this example, what I've been reviewing, like antibiotic lavage was used compared to normal saline lavage. Somebody must have done analysis on wound lavage instead of peritoneal lavage. Somebody might have done some infiltrating some antibiotic into the wound. So if we combine all these meta-analysis, all these studies together and do a meta-analysis, that is called network meta-analysis.
Yeah, there's a question in the chat box by Dripta. Sir, is there any minimum number of studies required for a meta-analysis?
So theoretically, there are 2 or more. So even if there are 2 studies conducted which can be comparable, we can do the meta-analysis. But to have a good results, to have a good valid have a good external validity, it is better to do meta-analysis on a topic where there have been multiple similar studies. Like if it is done in one country, many countries have been done, then we can extrapolate the results or generalize the results. But if we have only 2 studies have been done, that too in India, we can't generalize the results of those meta-analysis into.
In such a situation, it is better to do a randomized study or a prospective study based on the question of based on the hypothesis, rather than doing meta-analysis. The numbers.
Yes.
So any other question?
Sir, Drupta here. Sir, I wanted to ask.
So wait, more questions will take. Otherwise, we will end up. Yeah, please go ahead. Can't hear
Yes,
you.
Drupta.
Sir, I wanted to ask regarding the previous question I asked. Like if we have like a certain, like you said, like different countries that we have similar studies in, and like is there, like I wanted to ask, like to consider a meta-analysis over a topic, like like when do we consider it? Like when we have multiple studies in different locations, like is there any number, or is it like based on the researcher's choice? Like
It is
when do we decide?
if a researcher wants to come to a conclusion and he wants to summarize the studies whatever available, like if there are 2 studies also, 10 studies also, or more than that also, if the researcher wants, he finds that nobody has done a meta-analysis recently, and he wants to summarize the results of all those studies, then he can do a meta-analysis. 2 or more is sufficient. But the same thing what I would like to repeat is that it's better to do RCT on that topic which has got fewer number of studies rather than doing a meta-analysis to make the yeah.
So another question is like, does it depend on the results of the studies that are available? Like if we have conflicting results in different
one more thing is that there should be conflicting results also. It's if there are 10 studies and all the 10 studies have said that it is useful, then there is no point in doing a meta-analysis.
Oh, okay, sir. Like it should be conflicting and in different areas to extrapolate the results. And there is no minimum number as such there.
2.
Thank you.
2 or more.
Minimum. Okay. Thank you.
Hi, Debasis. Rajkumar here. Wonderful lecture.
Thank you, sir.
My question is, you said meta-analysis is about published and unpublished study, isn't it?
Yes.
So, and how do you take unpublished study into? If it is unpublished, how do you get the data from the unpublished study?
It's difficult, sir. But if it has been done properly, then it should include those unpublished. Like what happens is that some of the studies may not be published, but the protocol may be published in say like clinical trials. So from those websites, we need to search and we need to find if someone has registered a protocol. We can get the name of the author, the email ID, and try to contact that particular author and to see whether if he has completed the study. If so, what are the results?
And how do you find the experts in those fields? Repeated publication, the same topic.
Experts in the field. It can be known from, say, I am attending a conference. I find someone presenting topic or some presentation on similar topics. Then I can contact them as an expert. Since they have done something on that, they might be having some interest on that. So if I contact them, I can get to know that whether someone else they might be knowing has done any work on that particular review topic of interest.
Yeah, and one more thing is, do you take into account that unpublished study and the expert opinion as authentic? And can you put that in a meta-analysis and give an opinion based on that?
It is now it depends upon how reliable that source is. It may not be authentic in all the cases, but yeah, definitely we should include it in our meta-analysis. Similarly, if we think of like that, many articles, whatever published over in literature, may not be authentic. Some may be fabricated also. So we can't.
I understand that, but published is published. I don't know how unpublished data will be, because every publication goes through a rigorous process. I understand that, but still it is, the data may be fake.
It has got the disadvantage that it has not been peer reviewed.
Yes.
But
yes.
There are some review articles, sir. Like
Okay.
what they do is that they contact the authors, and even the authors would have published the results in study, but they get to know more about those study participants, more about the results which the author has not published, or he didn't find that time that these things are important to be published. So
supposing we are doing a meta-analysis on laparoscopic pancreatic duodenectomy, there is no, we can always take data from Rajkumar, even if he has not published. There is nothing wrong because we really Rajkumar's data.
yes, sir. Like if we feel that if we know that someone is working good in that field, and we'll definitely take their data. That will be a source of reliability if we know the credibility of the particular author or the person who is working in that field.
Thank you, Debasis. And one more question is, now you talked about meta-analysis and
Yes,
the
sir.
difference between systemic and meta. So now when do you do systemic, when do you do meta?
Systematic review is just a review of like, sir, scholarly reviewing the articles. We be very stringent in finding
The
out all
data is
the
more of qualitative in nature. It is difficult to do a meta-analysis. That time it's better to go for a systematic review. Okay? So when it is quantitative, it is possible to do it.
it's more of qualitative nature also. There won't be any analysis.
Thank you. Again, a nice lecture, wonderful lecture.
Thank you, sir.
I hope there are no more questions. We are getting late for the lunch. Can we take a break? Anybody wants to ask question, please raise your hands. We'll allow you another 15 seconds. After that, we will close down. Okay. Thank you very much. Thank you, Debasis, once again.
Thank you, sir.
We will end the session now.
Thank you, sir.
Recording